George for kicking us off with a wonderful song. I see some applause in the crowd there. Um, yes, hello and welcome everyone. As I said in the chat, it's so good to see some familiar names and faces with us tonight. Welcome to the Quimper Geological Society event for this month. My name is Rebecca Koronowski, and I am here to get us all situated and then to hand it off to Michael and to George to get on with our presentation. So if you are not familiar with Zoom, I will just give you a couple of pointers to start us off here. First off, we will have our audience with their mics on mute for the duration of our presentation, and that's just so our speakers can have the floor. But it's up to you if you'd like to have your video on or off. It's really nice for our presenters to be able to see who's in the audience, but we recognize that you may be hanging out at your desk doing something and not feeling like putting yourself on camera for the world to see. So we understand. Additionally, I will let you know that we are recording this presentation and we will be sharing it on the Quimper Geological Society website after the fact. We won't be sharing the audience video feeds, but just so you know, anything that you share in the chat that you bring up for discussion will be a part of that recording. And also, if you love the presentation, you'll be able to then send that link on to your friends to let them have a peek as well. In the upper right-hand corner of your screen, you have a couple of different options for how Zoom allows you to view the presentation. My favorite once someone is screen sharing is to choose side-by-side view with the gallery, but it's up to you which you'd prefer, so that you could either see multiple people in the presentation or to choose speaker view and just see the person who's live on the screen. Who's speaking live on the screen. Additionally, you may be familiar that we have the chat function available, and I just said hi to all there. And that is where we will be collecting questions for the Q&A session that will happen towards the end of the presentation. And so feel free to send questions into the chat. Choose the option to send to everyone so we all can see it. And then Michael and I will coordinate on curating a little Q&A session towards the end. Similarly, if you're having any technical trouble or just need some support there, feel free to use the chat to get a hold of me and we'll get you squared away. We do have closed captioning available for folks who are interested in using that function. And on the bottom of your screen, if you're on a computer, towards the kind of center right, there is a button called Live Transcript, and it has an icon that has two C's on it. And if you choose that, you can toggle between subtitles being on or off, so show or hide subtitle. So if you're seeing those now and you'd prefer not to, bottom of your screen, the CC button, and choose Hide Subtitle. And those are auto-generated, and so proper nouns and technical terms may not show up appropriately. I know Owen has a really fun time deciphering what all of those things are for us. So timing-wise, we will end the talk at about 5 o'clock with a Q&A to follow. So stick around if you have questions for George. And right now, I am going to launch a poll that you all will be able to answer and share a little bit about where you're from and what your geological background is. So if you're on a computer, you click the two answers and push submit. And if you're on a tablet or a phone, you may have to scroll down, but there will be a button to submit your answers there. Michael is here with me today, Michael Machette of Quimper Geological Society. And I'm curious, Michael, as you're seeing the results come in, if anything is surprising you.
Well, I don't know. I think I just screwed it up.
Oh, that's okay. I'll push the buttons. You just analyze the data.
Well, looks like more people than not from outside our county. So this Zoom thing is attracting people from the east side, the Seattle, Tacoma area, and even we get a few people outside the state. I know we got some Coloradans here because I've got some geo mates from that area. So that's great. In terms of your backgrounds, it looks like, oh, what I'm seeing, about two-thirds you have, probably two-thirds you have some sort of geologic background, whether it's undergraduate studies or you're professional practicing right now. So that's good to know. George is gearing this for the kind of 101 crowd, I think. So everybody should be able to keep up with it.
Yeah, here. So I will end the poll and share the results with everyone. It's just as Michael said. Great to have people from outside of the county. I'm curious if anyone, whoever has chosen the other for the geologic background, would like to share what experience they've had. All right, and I'll click stop sharing, and you can take it away, Michael.
Okay, thanks. Whoops.
Michael and George, you may have to click the red X on the top left of the poll to make it go away for you.
Get it there. It's gone for me, but I don't have capture of the screen yet. Can you turn me on?
For screen sharing,
Yeah, I guess so.
go for it. It
Well,
should be on now.
all I got was my desktop. Well, anyway,
There we go.
you don't want
Oh,
to you don't want to see that.
no, we don't.
Well, I'm sure it's screen scaring. I'm going to stop the share. I'll just talk, okay?
Okay.
Just a few notes about what's going on with the society. Sorry I didn't get up on your screen, but 2 inches of me is probably enough. Something happened special this week. Our membership reached 1,000 members. Not bad for a little puny geological society in Port Townsend. Sylvia Susan Smith was the one that hit the mark, and she was awarded a gift certificate for one of our next Quimper Geologic Society field trips. In terms of geology, she says she loves rocks since she was a little kid, excited to learn more about the geology of the Pacific Northwest. I think she's new to the area. So thanks for being number 1,000. I think we're at 1,015 right now. Upcoming events for our society, November 20th, Doug Clark. Oh, here we go. Oh, you can just read on screen. Doug Clark from Western Washington University in Bellingham will talk about alpine glaciations of the Pacific Northwest. Into the new year, but early, is Carolyn Dreiger of the USGS in Vancouver, Washington. She'll compare the hazards of Sierra Nevada de Luis, leave it alone, Rebecca, and Mount Rainier's volcanoes. Both have severe downslope hazards from eruptions. And then in mid-February, Marley Miller from the University of Oregon was going to talk about her book with Daryl Cowan on the roadside geology of Washington. If you haven't bought this, you keep it in your glove box, and when you take a tour of Washington, you can check out all the details of the roadside geology. And then we have some other talks scheduled for later in the year. So that's what we've got coming up. In terms of today, our speaker is George. You've already seen him perform on screen with his guitar. He earned his Bachelor of Arts from the University of Tennessee and his PhD from the University of Kansas. He's a professor emeritus and the former director of the University of Montana Paleontological Center. You know, Montana has a lot of fossils, especially dinosaur fossils. He was at the University of Montana for 35 years, where he taught and conducted research in paleontology and geology. His research has helped clarify mass extinctions, the evolution of reef structures, and modern and ancient coral lineages. George's scientific achievements are too numerous to mention here. You can check his webpage out, though. He's most noteworthy are that he was a Fulbright Fellowship, and he has an association with the Smithsonian Institution Museum of Natural History. He's a fellow of several scientific societies, and he's authored more than 300 professional publications and several books. His research has taken him around the world, but he's now largely retired. He lives next to the Chinese Gardens and in the North Beach area of Port Townsend, where he enjoys hiking, nature, and playing guitar, as you just heard. So, would you please welcome George Stanley speaking about mass extinctions in geologic time and its implications for the past, present, and future. George, thanks for coming.
Yes, thank you very much. And it's a big honor to be here. And I see some familiar faces that I know, and so I'm glad to see everyone here. And I'm going to be talking about something that I hope it doesn't turn out to be a total catastrophe, but that's what it's about. Mass extinctions, past, present, and future. And to start off with, there's a map from Ray Troll showing the area here, and he shows icons for where the fossils are found. You can see the state, the western part of the state is very rich in fossils. And you can maybe recognize some of them. Ray Troll is an artist living in Alaska that has maps and cartoons and all kinds of interesting things. So I live in Port Townsend. I've been there for, I've been here 4 years and I love it. One of the things I want to start out with is clarification, because this is for a general audience and a general science literate audience, which is becoming rarer and rarer. We have anthropology, which people confuse archaeology and paleontology. So I always want to make it clear that what I study doesn't involve humans, but everything else. There is an area of overlap there called paleoanthropology, but that's not my field. And might start off with a little quiz. What do all these images have in common? And people could look and say, oh, well, what they have in common is that they're all extinct. In fact, 99% of all species in the geological past are extinct. So extinction is a common phenomenon, as is the birth of new species. And you may notice that the gorilla ape is circled because it's not extinct, but it's on the way out if we don't do something soon. So one of the things to think of is, what is extinction? You know, the end of an individual is one thing, but the birth of another is different. So people don't realize that extinction is the severance of the entire species, genus, or family. It's forever. And people use it incorrectly. I've heard people say, well, this species is extinct in South America, but alive in North America. That's not correct usage. It's either all or nothing proposition. And so what is a mass extinction? Well, it is a geologically sudden dying out of large numbers of organisms, and just across the board, across life, all kinds of organisms, plants, animals, and even microorganisms. I noticed that I put this slide together because I've noticed over the past 5-10 years, the public is really enamored with extinction. And I think you see these books and movies and even a game about mass extinction. I think this reflects the public's really worry about where we're going and about how we could become extinct. What I'm going to cover is going to have some of our prominent heads here. Extinction in geological time. I'll talk about the legacy of mass extinctions, what's happening in the sea, talk about climate change and the recent past, and the future of our planet, a very important topic. And last but not least, what we can learn from all this, because I think there's something that we can learn. Well, Darwin said evolution was like a tree, and he didn't mean a literal tree, but there's a real tree. And what he meant was that, you know, all organisms come from some primordial beginning, and they're all connected. They all share some common DNA from their past. And so that is a tree. But here is a more realistic tree that I use for my classes. And it has, just for animals, it has icons for every organism group of animal. And you can see it is an interesting tree. I like this tree because instead of showing humans on the very top, it shows them off on the side. So we look over here and see the snails, the other mammals, our neighbors. So it confers no special status to any species or group. So what takes diversity away? We talked about what generates diversity. Oh, by the way, this is the difference between land and sea when animals actually and plants made the transition to land. Well, what takes diversity away is, of course, mass extinction. And Mother Nature, whatever causes mass extinction, is the Grim Reaper who really pares down the tree. So there's a search for causes. You know, everybody wants to know the whodunit. Myself, I'm more interested in what made these fossils interesting. And I think I'd like to start off by talking about three major ideas, old ideas about what causes mass extinction. And they are sex, drugs, and violence. They wanted to work rock and roll in, but they couldn't figure out a way to do it. And then they'd have all the things wrong with society. But sex is very interesting because dinosaurs being reptiles, you know, it was very hot at the end of the Cretaceous, and dinosaurs being reptiles, a reptile, when they're heated up, will stop reproducing or produce only males or only females. And that's could lead to an extinction. The drug part is equally interesting. And flowering plants came about the same time when dinosaurs were flourishing in the Cretaceous. And they were very different from other plants because flowering plants have alkaloids and chemicals that are pretty noxious and can kill you or send you on trips. And so ideas that dinosaurs ate these having no olfactory or smell organs, they just OD'd. They stumbled off cliffs and died. And so Gary Larson captures this very well in his cartoon, What Caused the Extinction of Dinosaurs. But the third one, violence, is the only one that can be tested in science. And that is that we were hit by a meteorite about the size of Mount Everest that crashed into the Earth about 66 million years ago, and not only annihilated the dinosaurs, but killed off 70% of life. And one of the most interesting aspects of science is the development of a hypothesis, the Alvarez Hypothesis, put forth by a father and son team who started finding this element, iridium, which is a rare earth element. They found it in clay all around the whole world, precisely at the boundary between the Cretaceous and the Cenozoic. And this was called the Alvarez Hypothesis. And they suggested that it was a meteorite. And they found the crater later on. And it's called the Chicxulub crater. It's located on the Yucatan Peninsula. And so a nice detective story where in science where this idea was confirmed and reconfirmed and reconfirmed. But there are many other factors which control it. Climate, besides meteorite impact, volcanoes, temperature, oxygen dissolved in water, sea level rise, ocean circulation. There are many things, including ocean acidification, which we'll talk about some of these. Well, let's look at the end Cretaceous extinction, because about that time, 70% of all species were wiped out. These were dinosaurs, other reptiles, all ammonites, these creatures called belemnites, brachiopods, foraminifera, and many others. It was a catastrophic event. But there's lingering doubts about the cause, the meteorite impact. And so In India, we have the trap rocks, the Deccan trap rocks shown here in Western India. And these rocks are produced by volcanism. You can see the many flows that occurred here in India. Over 122,000 cubic miles of lava extruded over a short period of time, covered a large portion. And the interesting thing is that these are dated precisely at 66 million years ago, exactly when the extinction took place, exactly when the meteorite hit. So it looks like a double whammy. And this is attributed to a hotspot. And some of you geologists know this. What a hotspot is that you get these plumes of material that come up from the, it's not, it's supposed to be an interactive one, but these hot plumes of material come up from the mantle and they erupt on the surface, as this interacting slide should show. And when they erupt, they produce flood basalts. And those flood basalts can produce, can carry all kinds of bad things for the environment, not only greenhouse gas, but many other things which can wreak havoc. One thing I want to come back to is that dinosaurs have been misused. People think of them as being antiquated, out of date, destined for extinction, so forth. But I want to clear this up because many people would call their car a dinosaur. You know, my car is a dinosaur. Well, it's a completely wrong. It is nothing further from the truth. Dinosaurs were totally adapted to the environment, and they went extinct because they were in the wrong place at the right time. So never call your car a dinosaur. It's the wrong terminology, as you can see in this commercial I found in the airport, an exhibit. So one of the interesting things is that for 20, maybe 15 years, paleontologists have been gathering data, meticulously gathering data on the ranges and the beginnings and the ends of fossils. And the numbers of species dying can be plotted up from this huge database. Geological time is across the top. And we can see all these spikes. These are mass extinctions, and they rise far above background level of extinctions. And these were really apparent very clearly. And among those, 5 of them stand out among all the rest. And those are the big 5. And they include the end of the Ordovician, end of the Devonian, end of the Triassic, end of the Permian, end of the Cretaceous. We use a K here so it won't be confused with Cenozoic for the Cretaceous boundary. And this little box here shows, this is the extinction. This little box shows the period of time when Earth was perturbed, the post-extinction time, when life was really bad. And it went on for a long time. Now, some of my students were quick to say, to ask, you know, why are all the extinctions at the boundary, the end Devonian, the end Permian, the end Triassic, the end Cretaceous? And could it be that the geological record was actually constructed reflecting these mass extinctions? And yes, they left an indelible record in the geological history in the strata, and these were picked up. Notice that some of these extinctions reached 95%. That's pretty phenomenal, 95% of species killed, and the range as low as 70%. It was a catastrophe. Now, I want to talk to you about the end Permian event, because that was called the mother of all mass extinctions, when we nearly lost all of life. And it coincides with another set of volcanisms, flood basalts. Over 3 cubic kilometers of lava was extruded in Siberia, a large area, and it unleashed a chain of events that affected the carbon cycling in both the atmosphere and in the oceans. And it would have been like Mount St. Helens times 10,000 erupting during that time. And it, of course, went up into the atmosphere, acid rain fell, and it killed life on land. Waters became anoxic or low oxygen, life died. It would have been walking along the seashore, you would have seen a scene like this. In the aftermath, greater than 70% of land vertebrates died, and more than 90% of life in the sea perished. And this is interesting. The life was perturbed for 5 to 8 million years afterwards. And so we call this a delayed recovery. Now, I want to talk about the legacy of mass extinctions. Now, everybody seems to be caught up on the whodunit, or what caused the mass extinction. I myself have not done research on that. My research focuses on the topic of this book, which is recoveries. I am more interested in what happens after the mass extinction, because suddenly, when you annihilate 70, 80, 90% of life, you create a vacuum, and evolution goes warp speed, and species proliferate. And sometimes the new ecosystem, which appears afterwards, is very, very different from the one before it. And in fact, it could very well be that mass extinctions are one of the driving forces that control the history of life. Now, I want to also talk about contingencies. And this is an idea in Earth history that it's actually an idea that one thing depends on another, but the opposite of it, the other idea is determinism. It's kind of like predestination. People think about how life arose and evolved as being, what you would predict, but not necessarily so. And I would support the contingency idea. And that is simply that an unpredictable sequence of antecedent events, like A, B, C, D, E there, any change along the way would greatly affect the outcome. So B would be responsible for C and so forth. And if we were to take out one, D, we wouldn't have E. We might have something like E, but it would not be E. So I want to play a mind game with you. And that is, let's talk about this. So here is the geological range of mammals. And many people don't know that mammals and dinosaurs arose about the same time, the exact same time. And dinosaurs went extinct, but mammals went on. And this is the 66 million year boundary. And then we have the age of mammals. Well, these little rodent-like creatures that were mammals lived in the understory of dinosaurs. They were in the nooks and crannies. They weren't going anywhere. But when dinosaurs died, they went from animals the size of rodents to lions and tigers and bears and elephants and giraffes and all these different kinds of creatures. And so it was a big event. And I would ask you, you think about mammals taking over the earth would have been predicted, but not really. What if they hadn't gone extinct and mammals hadn't taken over? We would not be having this presentation. Here's a part of the mind game. In 2019, maybe you heard about this, a meteorite came streaking out of nowhere, and it was the size of, it could have wreaked havoc on the earth. It passed about half the distance from the moon, and people were quite shocked because they had no idea it was coming. And yeah, so we better be looking for those. And but what about the big impact on Earth 66 million years ago that killed the dinosaurs and most of other life? What if it had been a near miss? Wait a minute, that doesn't make sense. It's either a hit or it's not. Why did we say that? A near hit. Let's say it was a near hit. Life would have been different. And so we would possibly have evolved intelligent life from Struthiomimus or these upright dinosaurs that were probably pretty intelligent, but a dinosauroid, a human that might have had intelligence could have evolved. It's possible if dinosaurs went on. We don't know. This is in an area of science fiction. So your might have beens. One of the things to think about is how, moving into a different subject, is how human activities today are altering the climate cycle. We all know this. And there's a statement here from the EPA. And just last year, 43.1 billion tons of CO2 was injected into the atmosphere. And that's a 2.3% increase. And I believe if aliens were living, it had come to Earth, and some people think they are, and they're walking among us, but if they were to look at us and try to understand us, they would surmise that our sole purpose in life was to inject as much CO2 into the atmosphere as possible in the shortest amount of time. And that we were a very self-destructive species. And the other thing I wanted to talk about was that you have another situation where you think about the sea. You know, people have heard about this. The sea is sick. We're having major problems, and people, the public, can't generally look at the sea because it's not exposed to them. It's underwater. But you know, they think about this: all the food that people need, and 76% of coral species are packed into the southwestern part of the Pacific and the Indonesian area. We have coral bleaching, which is a subject I study, which is killing the corals. It's called white death. And if you ever read this National Geographic, it's really interesting. It's about plastic. 18 billion pounds of plastic end up in the ocean each year. And a statement from Sylvia Earle, a very prominent marine biologist, that our actions over the next 10 years will determine the state of the ocean for the next 10,000 years. A pretty big effect. So the point is, we're having a crisis, and people say, oh, well, you can tell there's a crisis in the sea by the price of seafood. If you have gone to the market, you know what I mean. Used to be that they could not afford seafood. They cannot afford seafood today. Used to be they couldn't afford steak, but now steak costs more than seafood. One thing that's happening is ocean acidification, and that is where CO2 is dissolved into the water and combines in this equation here to produce carbonic acid, which eventually will dissolve, as it is dissolving now, small microorganisms. And so the consumption of CO2 into the ocean is really affecting us. Here's a diagram that shows how it would look at 375 parts per million, 1 degree temperature change, 450 to 500 parts per million, 2 degree temperature change, and over 500 parts per million with more than 3 degrees centigrade warming. And so you can see there's a critical threshold in which corals die, our reefs die, and it's pretty sad. And you know, right now we're approaching this. Where are we? Well, 411 parts per million. I had to change this chart because the old one was 400. We've changed that much since it was published. But anyway, a geological publication came out tracking ocean acidification and CO2 through time. Here is parts per million of CO2, and these are derived from various places. These are the data points and the mean and variance, and this the best fit curve on that. And this one is based on, this is based on plants. This is based on stable isotopes found in organisms. And then over here, we change to thousands of years. And we can see the change in CO2 here and how we're going up. I brought your attention to the PTM, which stands for the Paleocene-Eocene Thermal Maximum, which was a time we've detected 56 million years ago when there was a phenomenal rise, as you can see, in CO2. And it happened over a very short period of time. And it's being used as a comparison for what might happen today as we go through these various scenarios, the worst case being here. Even the lower case, less worse scenarios would be pretty devastating in terms of what would happen to the environment. Coral reefs that I study, we can see here from Charlie Varon a plot of, this is when coral reefs occur. These are the 5 extinctions along here. And this is the post-extinction bad time. And almost, well, all 5 of these mass extinctions witness a dramatic rise in atmospheric CO2. And 4 of them, not the Ordovician excluded, 4 of them record ocean acidification that would have been devastating to Earth. And this is very interesting to look at this. And so many times I give lectures like this and people say, well, you always show that life returns, but maybe not really, because people say, okay, well, business as usual, no problem. Life, Mother Nature will replenish whatever is gone, but humans won't be in the picture for sure. And this is that attitude is really a strange one to take. Population growth is another problem, and what happens is that we're producing too many people, and this is the curve right here, and you can see it's logarithmic, and it goes really far up. Oh, I had to correct it because this chart, we're now approaching 7.8 billion people. So this is a million people. So look at this. Black Death was there, and so. And we can see that even when Columbus sailed the ocean, there were 400 million people. Now we're pushing almost 8 billion. So this is incredible. And the number of people, of course, can relate to what's happening to the environment for sure. And we've got to curb the population somehow. What are humans doing today? Well, they're releasing massive amounts of greenhouse gases, as we know. It's transforming whole landscapes of the world. There's over exploitation of life. There's pollution and poisons. Think about the orange groves and citrus groves, banana plantations, where they're putting agrochemicals in. They go out into the ocean. There's invasive species, and all these things are pushing extinction rates higher and higher. And so here's an updated list of extinct species. And you can just see some pictures of them that bring to mind. These are icons. And, you know, some of these are keystone species. And if a keystone species dies, other species die with it. But, oh, I'm sorry. Forget that one. Gigantopithecus delirius doesn't exist, sorry. And then, but Homo stupidus does. There's Homo stupidus. And we may be causing our own extinction, which is a pretty sad state of affairs. Extinctions, if you've been reading the literature, have been shown to be much worse than we previously thought in articles that are coming out. I mean, they previously thought they were 10 times worse, but now extinctions are happening 1,000 times faster because of humans. And when humans came along, things really changed, and it surpassed the old estimates. Well, how bad is it? We can look at that from this standpoint of a chart, which shows the fossil record here. We can, using our paleontological data on marine species and mammals, we can see the number of species that are actually going extinct. And over here, mammals, birds, and amphibians shown here. And this is an average long-term average extinction. This is the current extinction rate of up to 1,000 times higher than in the fossil record. And so projected is pretty scary, more than 10 times higher than the current rate. Now, we don't have data for all animals, but we got pretty good data for mammals, birds, and amphibians, and some of the other species, but it looks pretty grim. And what I'm trying to say is history is our teacher. We can get data from the fossil record to show what extinction rate was like at that point in time when there were no extinctions, and what it's like afterwards. So it's a pretty bad forecast. Well, E.O. Wilson, which some of you know, a very illustrious population biologist, has a quote here that I really like. And he has published some books, which are very, very important. I think this one here should be required reading for everyone, The Diversity of Life. In my university, it was required reading for all incoming students. But Wilson believes that humanity has really initiated the next mass extinction and is rushing our fellow species to eternity. This book, I think, is excellent. Elizabeth Colbert, I don't know if you've heard of her, but if you've read her, some of you may have read her book. I was really taken by it. She's a journalist and a staff writer for the New Yorker magazine, and she has published not so much as a scientist, but as a journalist. And she's won Pulitzer Prizes and so forth. This is a quote from her. It's not just mastodon bones that are being thrown out as it was in the Ice Age. Humans are headed for mass extinction, largely due to their own folly. So I'd recommend the book, The Sixth Extinction. Well, the sixth extinction is here, some people say, and we're going to be the first victims. It could eradicate 75% of life on Earth. So how can we stop this coming sixth extinction, 5 and counting? Well, what can we do? And if it occurs, what happens afterwards? And who will survive? Well, the nice thing about paleontology is I can give you a hit list and tell you who died, what their environment was like, what they ate, and so forth for each species. And, you know, if history is our teacher, so we can learn a lot from the fossil record. And so I'd like to talk about these. Generally, the animals that do survive, and some always survive, are what we call generalists. They have a very wide range of behavioral adaptations. In other words, wide niches. Here are some of the ones. You may recognize some of these. These are animals that can survive because they eat many different things and they have broad niches. This one here is very interesting. Tardigrades are only 1 millimeter in size, and they're the toughest creature on the planet. They can go into suspended animation, dry out, and live and be revived after 50 to 100 years. And they can survive in the vacuum of space. They can survive in space. And in fact, an Israeli spacecraft crash landed on the moon carrying a bunch of these. So who knows, they may be lying on the moon, waiting, alive, but in suspended animation. Pretty tough creatures. They call them Extremeophiles. And you know, the idea is like a one-man band. Okay, if you have a wide repertoire of behavioral adaptations, you know, this guy can play all these instruments, but none of them well. And these are what the survivors were like. They were generalists. They were organisms that could adapt to the worst conditions that the mass extinction put out. So science fiction now. Ward and Brockman have come out with a book called Future Evolution. And it shows what might be the future for us. And here is our legacy, plastic mostly, buried in the substrate. And then above is an environment that's very bleak. And in that environment, dandelions have grown into trees, jackrabbits have become the size of kangaroos, flying cockroaches, and roosters have evolved to the size of T-Rex. Well, it's science fiction, but the whole point is that we have some information about the kinds of creatures that could survive. Oh, what have we learned from all this? Well, we've learned that the current extinction rate is orders of magnitude greater than the geological past. And we've learned that the hardiest generalists will be the ones who survive, and those that survive will be low diversity. And this is the really sobering one, not that I'm an alcoholic, but if it takes more than 100,000 years for the recovery to take place, that's a long period of time. And some of these mass extinctions were 1 million years or more before recovery took place. So what can we do to slow the extinction? Well, Tony Barnowski, a paleontologist I know, has come up with some ideas, and they are a no-brainer to reduce greenhouse gases and our carbon footprint. curb our population growth, stop having so many babies, and give more places back to nature, make more protected regions. Change the way we view ourselves in nature, a philosophical way, but I mean, you think about it. If you view ourselves as part of nature, it's very different from if we view ourselves in the biblical sense of a creature who has the right to control how the earth develops. And change our economic system, the one that values nature. E.O. Wilson has come forth with an idea that we should put monetary value on each species and show how not killing it, not letting it die would benefit us financially. In other words, he hits the pocketbook. And last but not least, my own idea is to elect the kind of government figures that can achieve these goals. We really need to do that. And I leave you with this reading. Some people want to know what they can read, and these are really good books I picked out. A lot of you are readers. This is Colbert's book and E.O. Wilson's book, and here's one on history of mass extinctions. Even a novel that I really like called The Sixth Extinction by James Rowlands. And this is by Richard Leakey and Roger Levin, but this is the son of the famous Leakey who discovered the early humans in Africa. And these are all good books. Oh, this one's cool. It's a post-apocalyptic pop-up book for kids. You know what pop-up books are. It's called Beyond the Sixth Extinction. It's fun, and you open it up and kids can understand mass extinctions and what's happening. So thanks for your attention. I hope I didn't go over time too much. And so I'll stop here and take questions, I guess. Is that how we do it?
Yep. Thanks very much. We can't hear everybody's applause, but Rebecca, do you have any list of questions for us?
I do. We have a couple that just came in through the chat, and I can hear the round of applause as well. The first one that came in was from Larry about an article in the New Yorker that said there was evidence in the Hell Creek Formation, Montana, for the tsunami and after effects of the Chicxulub meteor impact. Any comments? He wonders.
Yeah, I've heard about this too. It's not my specialty, but yeah, there was a great inundation of waves that came. I mean, you're talking about a tsunami that the world has never known, that hit Texas and kept going. But I did not know that it got as far as Montana. I would think it got as far as Texas. But the fireball that resulted, these fragments were thrown up into space. It was so big. And these fragments in space started on IBM trajectory paths back into the earth and started wildfires all over the earth. And these trajectories could have triggered tsunamis like events if they hit lakes and things like that. And at that time, Montana was in the sea. So could have very well, one of these fragments could have started a tsunami that was recorded.
Thank you. We have another question that came in. I noticed in your curve on extinctions over time with the 5 major extinctions noted that the baseline seemed to have a skewed distribution. We're getting into the details here. Has a skewed distribution where it rises in the Paleozoic and then drops over time to the present. Is that a reflection on evolution strengthening through growth in diversity of species?
Yes, it possibly is. And I don't know if people realize it, but we're living in a world now in which we are at maximum diversity. The Earth is filled up right now. And as we look through time, diversity has always been increasing. even though it was set back by mass extinction. So yeah, in a way, that's probably correct.
Okay. A question from Nan. Does land conservation, like land trust efforts, make sense from the perspective of the sixth extension concerns? I'm assuming she means extinction. So does it make sense to be focusing on land conservation in the face of the sixth extinction
Yeah,
from this perspective?
Yeah, that's very important. And so many people, of course, you guys are not like that, but so many people have no idea what's going on in the sea because they can't see the sea unless they go to the beach for a holiday or something. Most people don't know what's going on in the ocean. We need conservation everywhere, and these protected areas are so important to preserve species.
I absolutely agree. And I know that Nan was asking the question, hoping that that would be your answer as well. So Michael wanted to clarify a little bit further back when they speak of the increase in 2 degrees Celsius temperature change in the ocean. Is that the surface temperature of the ocean, or is that an average for the entire water column?
That would be an average
Okay.
temperature of the whole water column. Of course, it would be, you're right, it would be varying colder water below. And but one interesting thing is that when water warmed up and the temperatures reached the ocean and water warmed up as far as the deepest part of the ocean, there's an incredible amount of frozen methane all along the edge of the continents. And that frozen methane could have been disturbed by the warmer temperatures, causing it to bubble up and produce methane. Methane is like 10 times more potent as a greenhouse gas. And this could have exacerbated the whole problem.
Yes, that's a great clarifying point. Let's see. So another question for you. If or when, hopeful thinking, we have our next mass extinction, what new life forms are likely to arise afterwards? Are there past trends that can give us any ideas about this?
Yeah, that's a very good question. And I'm a science fiction fan. So I'm always amazed at how science fiction writers have really predicted. So we don't know, this is science fiction, but it's quite possible. Well, we know that they would be generalists. They would be species that are widely adapted, but we can't say how evolution will go. And that book called Future Evolution that I showed the picture from, is just an idea of animals that might survive. But we know the background of these kinds of organisms, and how they would evolve, though, is something that we wouldn't be able to predict accurately, but we would get some general idea about it. Just like we would say that the dinosauroids might have evolved intelligence.
Yeah, and I guess kind of jumping off of that, another question. So from Paul, humans have obviously proven to be pretty adaptable. And so in his mind, no doubt we are on the way for creating another extinction, but one might argue that we will continue to adapt and maybe in a modern dark age. So, there's a future for species outside of the human species, but what's going to happen to us, do you think?
Yeah, everybody's concerned about that.
Mm-hmm.
We turn out to be what they would classify as a generalist specialist. And we are organisms that can adapt. If the weather gets cold, we don't grow hair, we kill animals and make skins and so forth. And with our technology, we've gone a long ways. But I think that if the predictions are right, humans won't stand a chance. So one of my students said, "Oh, you think we're so hardy and strong?" You say, I'll take you out to Montana in the middle of the winter and strip you naked and throw you in the snow and say, okay, we'll see you at the same place next year with nothing. Would you be able to come back and survive? And so, we're not as hardy and strong as we might think. I think a lot of animals are much, much better. But yeah, I can't say that, but I think people would try to survive, of course, and it would depend, of course, how bad the conditions were in the extinction that were affecting us. And surely we would lose a lot of the population, and the people that survived would have to adapt somehow. But mass extinction is really being able to adapt. And the critical thing is the speed of which the environment changes. And in some extinctions, like the KT, where the meteorite hit, it was very sudden. Other extinctions were gradual and slower, and it would give species more time to adapt.
Yes, yes. And I feel like just adding in here that a return to a reliance on traditional indigenous and ecological knowledge may be a way forward for us to consider, how we can adapt in the face of these big changes, and what we can do to empower people who've been living in the places that they've been living in since time immemorial. That to me seems like a really important component of all of this.
Oh, for sure. Yeah, I agree.
So, kind of changing gears here, there's a couple of questions related to, what causes what may happen for the mass extinction. So Michael was noting that some of the lesser extinctions in the past could be a product of less than world shaking events. And John was also noting that beyond what you've mentioned, he's curious, what other threats do we face geologically? Example, Yellowstone, and has the evidence of lava eruptions decreased worldwide? So they're kind of getting at these maybe not catastrophic moments, but could you speak to that at all?
Well, I showed that figure. Maybe you remember it, with all there were actually 27 mass extinctions. Some of them were smaller, and they didn't rank up to be one of the 5 big. But yeah, those smaller extinctions. But the problem is there's no common cause. The causes vary a lot. And I think in order to answer the question, you really need to know what the cause is. There's even been supernovas proposed for causes. And if a volcano erupted like Yellowstone, it would surely alter the climate, just like we've seen in the past, but it wouldn't be as catastrophic as we're talking about, but it surely would affect things. One volcano can do it. Pinatubo erupted and caused a 1 degree drop in world temperature, and that's a lot for, and during the time of the KT extinction, the aerosols that were thrown up into this atmosphere lasted for years. And you can imagine total darkness or semi-darkness for 100 years. And photosynthesis would stop, plants would die, things would break down. But yeah, there's causes for a lot of these smaller ones, and some of them are pretty exotic in cause. But myself, I don't really get into this. I care, but I don't really research on the causes so much. I let other people work on that. And I work on, as I said before, the recoveries after the extinction. That's where I find great interest, because we may never know the causes for all these, but the interesting effects to me is what happens to life afterwards, where we go, and how life comes back again. That we can use to learn where we're going today.
Yeah, it's that applied learning aspect of it, right? It's not just knowing for knowing's sake. Um, yeah, so I just want to lift up that Gary was mentioning that you were reflecting well on the Earth Policy Institute's 4 goals laid out in their Plan B, um, and that the evolutionary tree reflecting the real reality also references sci-fi, and is a prescription for mitigation.
Interesting. Yeah.
Yeah, and I don't know this name, but Barnowski, is that one of the diagrams that you referenced?
Yeah, he's a paleontologist.
Yes, Barnowski.
He has some books and publications out.
And Gary's just noting in the chat as well, that you mentioned 3 of the Plan B's 4 goals. The fourth is elimination of poverty, largely by raising the status of women. Uh, and I'm not sure, guided by the drawdown project's key impact. So I'm sure that the two of you would have a very fruitful conversation if you want to follow up after the fact.
It's interesting that so many of them do coincide.
Yes, yes. Some new ones coming in. Michael, feel free to jump in if there's anything that's coming to you that you want to ask of George. Jim has a good question here. So, what are the top influences that lead to faster recovery? And is there anything to be done now to hedge our bets and prepare?
Well, that's a very good question, and it's on everybody's mind. And how some people think, oh, it's too late. We're doomed. We're doomed. All they say is we're doomed. But I really think that if we start now to reverse some of these trends, we can alleviate. We may not have as a mass extinction as big or an event as big, but we will alleviate things a whole lot. So, I mean, I don't think it's all hopeless. And there are things that we can do and things that seem like a no-brainer to do that could really help reverse these trends. And the primary one is greenhouse gases. And, all of it is political. And so many, one of my ideas was to elect people that can further these goals and to make it better for us to quicker. And, if we were to change our carbon footprint, if we were to stop producing as much CO2, it would take 10 years before we'd even see the effect of it. It's so slow. So it's so sad that we are not moving that way immediately.
Yeah, it becomes a political question very quickly, considering our individual impacts versus the
Yeah, a
impacts.
world question too.
Yes, yes, a world question. Um, Willie and Janet would like to know what ramped up evolution would look like, which I think is a very interesting question as well.
What ramped up evolution would look like. Oh.
Yeah, so if evolution started happening quicker.
Oh yeah, I see. Yeah, I talked about after the mass extinction. This is why I find it so fascinating to study the post-extinction phenomenon, because evolution normally, as we see it going, the evolution of new species, yeah, we can observe that, but we can't observe mass extinctions. Only we can look at the fossil record of them. But whatever happened is that, like I say, evolution went warp speeds. Nature began spewing out new species, and it's kind of like a bottleneck. You hit a bottleneck, and then life passes through that bottleneck, and they immediately explode. And one of the interesting ones is the evolution of mammals. All those mammals that we have today, what incredible variety came from animals that were, no bigger than this, rodent-like animals. The biggest giant in the dinosaur time would have been, a raccoon size, but they all radiated so quickly. And in the Eocene, by the Eocene, we had camels and elephant groups and horses and so many different kinds of mammals so quickly. And it's amazing how fast these species are turned out and new groups appear.
Okay, George, can you hear me?
Yeah, I can hear you.
I'm thinking it's running after 5. We've had, 15 great questions. People probably have some more burning ones. Can I put your email up in the chat room?
Yeah, please do it.
Okay, I'll do that right
I'll
now.
be glad to.
So if you guys can capture that, you can continue this conversation with George. George, that was a fascinating presentation. I learned more about evolution than in all of college. I
Thank you.
appreciate you taking the time.
It's a pleasure and an honor to do this, and I really hope to hear from some of you. I see faces that I know, but I'd be glad to communicate. I really miss teaching. I miss my students a lot, but I've decided to start teaching some classes for adults, which turns out they're the best students.
Okay, so maybe a little virtual applause for George and thanking him. I know you can't hear that.
I can hear some.
Okay. Thanks very much, everybody. The next talk, November 20th, right here. Rebecca at charge. Thanks for coming.
Goodbye, everybody.
Thanks,
Thanks.
Al. Thank you so much, George.
You're welcome.